This is the fifth video in the Introduction to Simio module, and in this video we'll look at two primary things. We'll look at experimental responses, and we'll look at experimental responses for existing metrics as well as for newly computed metrics. And second, we'll look at s'more plots, and a s'more plot is a clear and concise graphical method to display replication results from simulation runs. So we'll use the flowline model that we've developed in the previous couple of videos. So if you have that, you should open it, and if you don't have it, you should go back and then reproduce it, because we will start from here assuming that we have it. And the first thing that we're going to do is looking at creating something called experimental responses that you see here in the graphic. And a response is an expression that's evaluated and then displayed at the end of a replication. So where the pivot grid, we go to a different view and filter down or sort to the results that we're interested in. A response directly reports the values in the design window of the experiment. So let's go to the experiment and look at creating those responses. And so I want to create 4 responses here. Back to our model here. I want to create one response for the utilization of server 1. I want to create a response for the utilization of server 2. I want to create a response for the average number of entities in the system over time, and I want to create the 4th response for the average time in hours that an entity spends in the system. So again, from our model, if I go and say run our experiment, I can run, and then I can look at the pivot grid. All of those metrics are available. So for example, if I go to my default entity, I can see the average number in system is 6.0759. The average time in system is 0.2471. If I go to the server, here's the scheduled utilization for server 1. And again, I scroll down and I see the scheduled utilization for server 2. So the information for these is already there. I simply want to record that, or I want to report that information as an experimental response. Okay, so to create our response, I'm in my experiment design view. I'm simply going to click the add response, and when I click that, it adds a response to my current experiment. So I'm going to go to response 1 and change the name. This is going to be utilization of S1. I'll just call it US1. And then I need to now tell Simio, remember that an experimental response is an expression that's evaluated at the end. So I want to just use the expression builder and construct that expression. So I know it's server 1, and I know that I want the capacity, and I want the scheduled utilization. So again, in this case, I just used the expression builder to navigate through the objects for server 1 to identify this capacity utilization. So then I run, when I run my model, we now see that that scheduled utilization is reported as a response. That's the exact same scheduled utilization that we saw in the pivot grid. In fact, it's the same number. So I can do the same thing for response 2, and we'll call this US2 for utilization of server 2. And in this case, I'm just going to go back to US1 and copy the expression. So I'm just going to use Control C, copy the expression here for Control V, and then just go in and change this one number because it's server 2 rather than server 1. And as I mentioned before, when we are adding new components to our model, wherever practical, it's best to go ahead and run the model and make sure that you have what you want before you move on. So in other words, I'm going to run it here so that I make sure this response is correct before I add the next one. So I reset my model. I have my two utilizations. The next response I want to add is the number in system. And so the number in system is a population statistic. So I have my default entity, population, number in system, average. And so that is the expression for that. And if you think back, or if you remember back to our video where we had the top 10 expressions, this number in system average was one of our top 10 because we see this frequently And again, don't worry about the fact that I'm constructing these very quickly, and that you don't. It will take more time for you to learn what the basic structure is. But once you do, you will find that this is a fairly straightforward way to present. And so the final one we're going to do is time and system. So I'm going to call this TIS. And then I'm going to build the expression. And there are two simple ways, or two straightforward ways I can do this. One is that I could use that same population statistic. So I could go to default entity, population, this time time and system average. And this would in fact give me that average. Let's go ahead and look at that. Before I do that, let's change the unit type. So the previous two, so I had the utilization and the number and system didn't have particular units. They're just standard units. But when we have time and system, it's a time. And so once I specify that it's a time, I can use the display unit. So if I wanted to see it minutes, I could make it minutes. We'll just leave it in hours, and we'll run the model. And so now we have our statistics. We have our 4 responses reported. As I said, we can report the timing system in 2 basic ways. One way uses the population, which is what I just did. A second method just uses sync1, and I can calculate the time and system for all of the entities that go through sync1. And so we can go back to the experiment, and let's just replace this expression with that expression. And again, we don't know exactly what it is, but we know it is tied to sync1. So sync1, and we see right there we have a time and system, and now we have an average. So now we have sync1.timeandsystem.average, and when I run, we should see we get the exact same value, right? We get the exact same value for our time and system statistic, which should be what we expect, because for this simple model, the entire population of entities goes through sync1. If we had other opportunities for entities to depart, so let's say, for example, that I have another sync here, and that some of my entities departed here, right? So now I would have 2 different syncs where some of the entities would travel this way and some would travel this way. Then the sync1 statistic would be for those entities that go this way. The sync2 statistic would be for all of the entities that go this way. And the population statistic would include the entire population. That gets a little bit ahead of where we want to be. I just wanted to mention that that even though in this case we're reporting the exact same thing, in general, you have multiple ways to report similar statistics to facilitate model flexibility. So we have our 4 statistics, which are based on existing metrics. But before we do the calculated metrics, I want to talk just briefly about the notion of a name versus display name. And so if we look back to our model, let me grab our model here. Back to our Simio model, there we go. And when we place these responses, you can see that we have 2 things. We have a name and a display name. And so the display name is what you actually see. The name is what Simio uses internally to reference that object. And so there are some specific rules that we have for names, because it has to uniquely identify a model component. So if I wanted to deal with internally, when I wanted to use this for computations or for display, which we'll see later, I need to have some way to uniquely identify this. But for the display name, it can be quite a bit more flexible. So you can add spaces, you can have special characters, and so on. And so you can decide when you're building a model, whether you want to use whether you want it to show. So when I created, you'll note that when I created these, I just put the name in, and then it defaulted the display name to whatever I typed. And so if you want that to appear differently, this is where you would do that. Okay, so finally, the next thing I want to do is, suppose I want to compute a new response. And so for our simple flow line, what I want to compute is something called the throughput. So think about our model. I'll go back to our model here. And what I want to compute is the throughput. Entities travel through the system, and I want to compute the rate at which entities go through the system. So if you think about that, I have 2 things that I need to do that. I need to know how many entities go through the sync, and then I need to divide that by some period of time. So I'm going to go back to my experiment, and I'm going to add the response, and I'm just going to call this throughput. CH02, and I'm going to start out saying, okay, well, suppose I just recorded the number of entities that went through the system, right? And so I can do that on the sync, because in order to go through the input buffer, number entered or number exit, let's do number exited. So we have the statistic of sync1.inputBuffer.number exited, and as you would assume, that is the number of entities that have gone through the sync's input buffer. And that would, for our model, be the number of entities that went through the system. So now I'm going to run that, and you can see that what it reports is the average. Remember, we're running, while we can only have integer number of entities, we ran 10 replications, and so what's reported here is the average over those 10 runs. And so this says 584 entities went through the sync. To get the rate that we want, I now need to divide that by the time value. And so the ending time value of a run is the value time now. So the model state time now is the current simulation time, or the current simulated time as the model runs. So at the end of the run, this will represent the duration of the model. And so in this case, we had our model running for 24 hours. Right, so by default, we didn't change any of this. The default runtime is 24 hours. And so to get our response, we are taking the number of entities, which was on average 584, and then dividing that by our time, 24 hours. And so when I run, this tells me my throughput is 24.37 entities per hour as the default time units. So for constructing any of these responses, the critical thing that we had to do was first understand what we wanted to report. In the case of the first four, we were reporting things that Simio collects for us automatically. And so as we demonstrated, we could go back to the pivot grid and find those values. For the throughput, though, it's something that we needed to calculate. So again, we needed to understand what we wanted to calculate, and then we needed to figure out how to extract those values from Simio. And don't worry about the fact that you wouldn't know off the top of your head how to get this number exited and the time now. All of that will come through use or through practice. The critical thing here is to just understand the methodology for creating these experimental responses. The last thing we will do in this video is to introduce something called a SMOR plot, or a Simio MOR plot, where MOR stands for measure of risk and error. And you see the graphical depiction here. And let me jump back into our Simio model here for just a second and show you how we get there. So one of the secondary benefits of having responses defined, if I just pick one, like let's pick time and system, I now can go to my response results, and Simio gives me this SMOR plot. The difference in the one that I showed previously is that I have the histogram shown. And so we're going to talk much more about SMOR plots when we get to experimentation and statistical analysis, but let's talk just very briefly about what this plot tells us. And so the plot has a number of components, and you can see what we have is it's very similar to a box plot if you're familiar with that. But what it's displaying is the mean value of the response, so the mean value over the number of replications, the confidence interval that's computed on that mean value, and we'll talk about that statistical definition a little bit later if you're not familiar with that. We get the median value, the upper percentile, the lower percentile, the corresponding confidence intervals for those two percentiles, as well as the maximum and minimum value. So it just gives us a graphical representation of the individual observations that we saw when we replicated. So let's go back to our model, and while we talk a little bit about this, what I'm going to do is I'm going to go back and I'm going to increase my number of replications to a big number. Let's make more than 100. Let's say I want to do 1,000 replications. And then I run, and while I do that, I go back to my response, and you can see that the SMOR plot is being dynamically updated. And there are a couple of things to notice here. First thing to notice is the confidence intervals are all getting smaller, and if you have a statistical background, you would recognize this, the fact that the more replications I do, the more confident I am in my estimates. And now the the change in my histogram is stabilizing. So we're actually estimating the actual probability distribution of that expected value. And so now we've run our 1,000 replications. And so now we can look at these individual values. So there's the mean value. We have the confidence interval range. We have the upper and lower percentile values that are automatically computed for us by simply specifying these as a response. Also note here I have control over the statistical parameters, so I can specify the confidence interval, alpha range, and the upper and lower percentiles for it to compute. So again, when we get to the experimental a section on experimentation and statistical analysis, we will delve much more deeply into what this means, how to interpret these values, how to use these values for your design. But what we wanted to show in this video was just one of the uses of using experimental responses is to provide this graphical technique for analysis.